Ready, good to go. Hey guys, hello dear speakers, dear audience, those of you who have survived this crypto winter and continue surviving, going strong, less people standing. So, good to see you here. My name is Sergey. I would like to talk about the third product of the Cyber Congress, which is the browser. I'll talk about the future browsing, browsing 3.0. I'll talk about the specific implementation of those ideas in our product, how we implement our vision of Web 3.0. Next-gen Internet, or Web 3.0, aka Web 3.0, is a very debatable topic. It's very ambiguous. There are many people talking about this. Multiple concepts exist. New concepts of the new web emerged in the middle 2000s. They were talking that web should be based on a semantic web. The decentralized and blockchain systems kicked in later. So let's handle this. To understand what kind of web we're supposed to have now, let's take a step back into the history, how browsers started in the first place. In late 60s of last century, the most basic protocols to describe the interaction of computers in the network, and the first networks appeared. They emerged as a result of scientists and military development. They were long time they were not available to users, to the broad circle of users. However, later on, with WW, HTTP, HTML, URL, time passed by, late 80s, the Web 1.0 came over. This was a new commercially successful web. It was commercially successful. There was a web with hyperlinks, with simple documents. The content was static. All you could do is read it. So at that stage, the web browser appeared. It's exactly when the browsers become trendsetters. They start to popularize the network technologies and applications that we are still using as of today. This is very important because the first thing the users see is the browser when interacting with the web, of course. So the first browsers that came around, these are the Logic, the Mosaic, the first GUI browser. Then there was Netscape Navigator, IE, the browser was started, which is still ongoing. Web 2.0 meant more complicated content, more complex content, more complex interactions between the stakeholders in the network. Web 2.0 era started. It is associated with the concept of reading and writing of dynamic content. Around this time, blogging tools and social media became popular. The browsers, the notable additions are Safari and Google Chrome. Google Chrome is in the lead, is dominating the market share. Web 3.0. We would like to immerse, we would like to delve deeper into this, start using it more actively. But hey guys, let's think about it. Let's think what we're not happy about in the Web 2.0, in the current web. The current web issues, the current paradigm. The browsers that support this Web 2.0 paradigm, it has these shortcomings, performance or lack thereof, speed. Internet is slow right now. There are many bodies of research. There is a big body of research that shows that people perceive fast the time frame of 100 milliseconds. 100 milliseconds and less is fast. The current DNS protocol, the protocol stack, including DNS protocol, does not provide for content obtaining in that short time frame. At the same time, caching and deduplication of content are not resolved in Web 2.0 to make sure that the content arrives fast. Coherence and control of the data. Well, currently there is a tendency to segment and single out the regions of internet based on the geopolitical location of the specific segment. Now, this segmentation can be easily done by persons who have certain resources at their hands, such as high-tech corporations, big ones, multinationals, and governments. Security. Well, it's obviously very difficult to build a secure system using third parties or intermediaries who work on a very unknown principles, on principles of operation unknown to the vast majority of people. Privacy, currently, yes, traceless web exploration is currently impossible in the current web. Business, multi-billion ad business and user data market is there. because of this. Decentralization. Web 2.0 has a very low number of failure points, root DNS service, and major cloud providers. We would like to make sure that Web 3.0 will handle all these issues above. The idea, the most recent idea of Web 3.0 was introduced by Gavin Wood in 2014. We developed this concept. We singled out 4 key components that affect Web 2.0 architecture: content addressing, crypto identities, consensus computing, and browsing experience. They are listed in more detail in the white paper. I'm going to reference, give you a link at the end of the presentation. I would like to focus all these concepts, but primarily the browsing will be the main feature of my presentation. So let's talk about the entities, the roles that exist in Web 3.0. There is no strict division in the new web on users or into users, providers, and sites. This division can be applied, but only in the context of their interaction. These are the key entities. One identity is Web 3.3 agents, the entities that own private keys and can sign transactions. Could be people, could be robots, could be special software, any diverse life form that we might not even know exists. Web3 providers. These are the systems that process the information and the knowledge about Web3 agents. Every Web3 agent can also become a Web3 provider. The example was showcased by Valera, the previous speaker. Web3 apps. It's any content which can be authenticated by its address. So what is the place that Web3 browsers take in this paradigm? Well, most likely Web3 browser can be defined as a special software that can help Web3 agents interact among themselves, interact with applications, and interact with Web3 providers. I believe these guys, these logos here, you've heard a lot about them. You must be using them day in, day out. They are working, they're operational, and they are, to that another extent, Web 3.0 part of the paradigm. However, when we're talking about interaction with proper Web3 content, there are many inconveniences and challenges that arise. It's not just about speed and stability. It's not about performance and stability. It's more about vision and philosophy. This is about how it looks like, the way of interaction with Web3. This is the way the current products look like. We believe that the picture is somewhat different still, and the entire Web 2.0 can be viewed as an unsafe, unsecure sub-entity or subdomain, sub-aggregates of Web 3.0. So the new paradigm requires fundamental reconsideration of interactions between network participants. We took some time to consider it, and we decided to go ahead with a solution that will reflect our vision, our philosophy. This is Scybe browser that we would like to introduce. It is operating only on the Web 3.0 functionality. It only has Web 3.0 functionality, but we are thinking about prompt integration of 2.0 as well. Why Scybe? Scybe is a friendly robot. It's the name of a friendly robot whose mission is to show the users the world of the new internet, brave new internet. This is the paradigm, or this is the way to help navigate this unfriendly world sometimes. Browser structure, its components, I'll be showing this to you, not to sound empty. I have something to show for it. The browser is composed of the shell and root apps. The shell is the main page, the dashboards, navigation panels, applications account, and the connection status. Pretty much everything we used to in Web 2.0. Root apps, I'll talk about them later on. They're unique for this browser. Right, let's start with Web3 providers. Our browser can work with 3 providers: IPFS for content addressing, CyberD provider for searching and accessing knowledge graph, and the Ethereum node. That's the provider to work with the Ethereum network. The users can can give their own access points to existing providers, connecting to local nodes or remote nodes, thereby optimizing their operation. Or they can pre-select a provider from a list which is formed from the marketplace that Valera talked about. So let's get to demo. This is the main page. This shows the most basic functionality for operation and connection to the Web3 providers. The colors reflect the status of connection. So currently I have a local host reading IPFS. IPFS read and IPFS write. I am connected to CyberD Ethereum nodes, which are deployed at our office PC. A couple of words about content addressing. The thing is, the URL standard, which is actively leveraged these days, it first answers the question where the content is located and then what kind of content that is, and only then how to open it. That causes us to have to know for a fact which server stores the information. This is the way URL looks like, the URL that is responsible for opening the content. Our concept was called Dura, which is described in the Vision white paper. You don't need to know the location of the content. The address itself contains the CID and contains the information how to receive it. The browser only needs to figure out which application to use to open that content. Currently, there are several protocols that describe content addressing: IPFS, Ethereum Swarm, and DAT. In our browser, we only went with IPFS protocol. Root registry. Our alternative approach to handling DNS in Web 3.0. Root registry, RR, is a simple registry in Chaingear where application hashes and their names are correlated. That correlation registry is required for the browsers to understand how to process Web 3.0 content. This is the way it looks. A pretty simple spreadsheet, a table that lists the name and the IPFS hash. So, the browser helps the user customize this registry for their purposes, for themselves, which means we can receive a fully decentralized application. You can use a registry that is shaped because of market economy in Chaingear, or you can throw in your custom DNS registry. However, in that case, it will only be available for your browser, for your client browser. Searching, definitely browsers are supposed to be able to search. At this point, the browser can search for data which are added to the CyberD KG and also view the content which is available through IPFS hashes. The browser can also help users affect the search feed. They can either amplify the ranking of the result or to append and link their own results to a specific query, thereby appending the KG, the knowledge graph. So let's try to do a search here. Nothing found. Okay, but I can add my own custom feedback. So, hello, how are you? Привет. Linking it takes a bit of time. Okay, hooray, we have just linked our search query. There is a rank on the right. If people keep using or keep following this link, then this rank will increase. It will become amplified. We just linked a new search result to the query. Now, Chaingear. A couple of words worth mentioning. Browser uses Chaingear as an application that can work with smart contracts. Chaingear can be used by the browser as an application to form key system registries. Application registry, root registry, Web3 provider address registry. We use it as a root registry, as an app store, as a node addresses storage, as well as the team registry, Cyber Congress team, and the registry of features. So let's try and create a couple of registries in Chaingear. No, it's Kova at this point. Unfortunately, we're having some issues with accessing to mainnet. That's transaction confirmation window. That's right. That Fox, it's a legacy from MetaMask. However, the history of the browser is very curious. It wasn't always the way it looks now. It didn't always look this way. We also started as a Web 2.0 browser. We made a web application that could have been opened in Chrome, so that sounded a bit weird. The browser as is came out possibly 4 months ago, around 4 months ago. It's still experimental. We're not always aware of how some features should look like, so we're just showing it to get more feedback. We're showcasing it to get some feedback. Great, so we've created the registry. Let's establish a structure that will help or that will enable us appending the entries. Yes, so we believe that the new web is going to be faster than that, than the status quo. We're working to get there. So, perfect. We've established the registry. Now, this address is the owner. This address here. So, a lot of interesting stuff can happen here. I can send money to this registry. Anyone who wishes to can do that, to vote for it, to vote with the money. As an owner of this registry, I can withdraw that money, I can transfer it to a different account, I can transfer this registry to a different account. It will play by the other host rules. So I can create an entry. So let's try to append or add an entry. Hooray! We have a blank entry here. This is normal logic. Now we're supposed to fill it. Perfect, it worked out. So anyone who wishes to can access our browser. No cheating here. Everything is legit. Okay, let me continue. Transaction and nav history. SIBE can store the history of user movements and transaction activity, and this data is only available to the user himself or herself. Web 3.0 creates an additional problem. People need to monitor their transactions at all times. That transaction monitoring issue has not been addressed properly. So we decided to proceed from this blunt force to the brute force solution, a very banal, trivial solution. Just a list of transactions. The manager of lagging transactions or suspended transactions will be featured soon. This will enable those of you who have played Dragons. So you remember in MetaMask how unpleasant it was to send a transaction with small gas vice and wait for hours and hours, for 5 hours, to not be able to cancel your action, your erroneous action. Right, so that's the history. It's pretty self-explanatory, something we've seen in Web 2.0. App development. For a web app to be available in our browser, anyone can develop one, can get an IPFS hash and register it in the Chaingear app registry. In that case, it will be available to all the users. Our colleague Ales here, for example, has used the .help application where he publishes small tutorials as how to work with the browser. So this is the way this app looks. The most basic HTML pages. That's how it looks at this point. .help. So yeah, you're supposed to start somewhere, start small. Hooray, gaming. Definitely, we couldn't ignore the Dragon Fever. I'm talking about Dragonirium game, a Web3 game that many people are playing through our browser for 2 weeks now. People who have seen the blockchain in Web 3.0 for the first time ever, they noted the comfort and naturality, the ease of use, ease of interaction with the game through site. So somebody accused us of launching this site as soon as possible so we can mine more gold and buy more dragon eggs. Well, like I said, it's free access, so everybody could have done that. It's just a question of motivation or lack thereof. So let me just switch to a different network. Yeah, I'm about to do that. The question is the connection robust enough? That's right, not all the data is cached at this point, so it's still an open question for both for Web 2.0 and Web 3.0. Finally, confirmation. That's the transaction that got sent. That's it. The gold has been purchased. Thank you. Right, the roadmap. So I've shown something we have now. Possibly this is the most high-tech stuff, the most breakthrough stuff. But I believe we're moving in the right direction. We've taken the right path. One step at a time, incrementally, experimentally. Now let me tell you how we continue to develop, how we plan to continue to develop our browser, what are the issues we want to handle next. Security. We warn users at this point that this browser is experimental product. Currently, this is the way it is. Its use with real money is definitely risky. Soon we will publish a bounty program to search for vulnerabilities. We will work to encrypt user data and enhance the algorithms. Access control. You may remember those times when you open a web browser, Chrome, 3, 4 tabs, and at some point one of the tabs starts consuming resources like crazy, hardware resources. And you can't figure out what to do that. We believe that this is disrespect for the users. Web 3.0 must be free of that. Therefore, our applications and our browsers must play by the rules set by the users. Could be a limit on the computational resources, could be a limit on the storage and on the hard disk, could be control of traffic use, hardware sensors and probes. This can be customized by the user. Access control, there is no data storage on the remote servers, so it would be great for users to determine which apps can access the data inside the browser. More Web3 providers. There's more and more consensus computing protocols by the day, by the minute, more consensus computers themselves. We want to find a simple approach to adding new Web3 providers like ETH2, ETH 2.0, Polkadot, Cosmos, EOS, our browsers, our top Web3 browser must be free of such notion as listing of that or not technology. A developer can provide integration himself or herself and making it available through a simple publication of hashes. Yes, it's a very relevant issue, you're right. You're correct. You remember this list here? This list here, it will continue to grow exponentially, and we must keep a lid on this. It's not always obvious how to interact with multiple providers over multiple networks at the same time. So that's also something we plan to handle next. And this bit here is also very interesting. So we're very close to handling multi-crypto wallets. At this point, we have the most basic POC wallet that can import wallets, can import accounts, can create accounts in Ethereum and CyberD. You can send tokens around. However, when more blockchains emerge, they will need to be integrated somehow, and users will have to deal with privates, with accounts, with addresses, figure out which goes to what with the correlation. We believe that the way around that would be a crypto identity. Our team is thinking about a crypto identity that can help the browser find the addresses in multiple blockchain systems without bothering the users with that. Moreover, we'll need to think about the creation of an additional abstraction layer for a wallet so that you can work with that. The browser will then use the identity as an intermediary between you and the wallets you're using. Delegation of signing. In Web 3.0, the minute changes of the system system state are accompanied with transactions that need to be signed by the users. Now imagine hundreds and thousands of those transactions in a single day. Well, even Dragonirium showed that it's not convenient to every time click that confirmation transaction in MetaMask. That somehow is a separate pop-up. A logical solution to it would have been allowing the browser to do this automatically for you. You can define the limits of signing. You can define some rules or the deposit limit for transaction committee, transaction fee, and the browser will act accordingly, automatically based on what you said. Better offline operation. Well, definitely offline operation is not just about caching granted to users, but also about working with the state locally, like signing the transactions. Best dev tools. We are not simply working for the benefit of advanced Web 3.0 users, but we're also developing dev tools for convenient development and testing of applications of next gen in our browser. I would like to voice my gratitude to the team. The third time over is not enough to do it. Third time, I'm thanking them. Thank you guys for making our world more comfortable, more better, more accessible. Thank you guys. Thank you, Sergey. Any questions? Yes, my presentation is about to be concluded. I'll be happy to take your questions. These are Web 2.0 links to the browser white paper and the Web3 vision philosophy. That's it. Thank you. Yeah, the presentation is definitely available on IPFS. Like this. Like that. Here it comes. All those of you who are interested, I can send it into your hash. I can send the hash into your chat, so please feel free to approach me with your questions. Next, browser leverages JavaScript, React plus Electron. Possibly further questions? Well, APIs, it's a very good question. We're getting there. We're working on it. So far, we've been thinking about the ease of adding registries into Chaingear, the ease of you adding your apps into the Chaingear registry. This is the Paramount thing, the Paramount API that we made happen. Dima, can you remember it? Yeah, the APIs are pretty easy, so we're going to support this, traditional web providers. If the app works with MetaMask, we will enable the support in our browser as well. But our approach is more like this. Oh, there is a check. You can check whether the application is launchable in the browser or not. And maybe think about some custom logic that the application developer wants to happen for a specific browser. Like, for example, this Dragoneer integration was very interesting. Now, when you're playing from Chrome and you sign a transaction in Chrome, the game can only reference the hash of the transaction, never scan. And that's very disruptive for the gameplay if you want to check the state like that. So Sergey, can you show it? You can obtain, you can follow a link from the game without any ever scan. Yeah, I showed that when I was buying the gold. No, the transaction switch. It's a very specific point. No, yeah, I might have missed that. So you can. There is a check whether it's SIBE or not, and then you can create some customary logic for SIBE. It's a very simple idea that doesn't require an API per se. More gold. You want me to buy more gold? Yeah, while it's slow, yeah, it makes sense to buy gold. Okay, no further questions. Okay, if there are none, well, so let's meet at the networking session. Please approach me with any questions you might have. If you feel shy for some reason, to ask them now. Thank you, guys. Thank you, Sergey. Round of applause to Sergey.